Hello everyone, my name is Andrew, I'm from Arrowstream, and my colleague here, Mark, is here to help you understand how we can actually make data warehouses out of survey data. So it's kind of a bit of a weird subject. There'll be some people in the room who don't know what a data warehouse is. There'll be some people who kind of know what it is. So hopefully I'm going to try and demyst things a little bit. Why I feel like I can stand here and talk about it is because for the past 3 years I've run my own company delivering dashboards, so using the modern data stack, but with survey data. And in order to do that, you have to put data into a data warehouse to make that work. If you don't do that, things like Tableau, things like Power BI, they just don't work very well. And so what I'm going to try and do, in the kind of good honour of ASC, if I can ask one thing, if you could move that way, I'm going to introduce those little whiteboards. Sorry, thank you. Where was I? So what I'm going to try and do is really open up the black box which I use to show you how it all works. No holds barred, I'll show you everything. But we've only got an hour. And also I'm trying to make this an interactive workshop. I've fed up with PowerPoint, so we're using flip charts. I'm just done. So I'm trying to, what I think is probably one of the most technical things without using technology. So what we're going to try and do is, first of all, kind of talk about the meaning why you need to use data warehouses, and then relate that to survey data. Then I'm actually going to talk us through a model for using that we can use for our survey data, and I'm going to get you guys to build that model with us. And at the end, I'm going to put it all into practice and show you what it then looks like when you actually formulate it, Excel spreadsheets, SPSS files, Tableau workbooks, and then see what happens. Okay? Does that sound okay?
Yeah.
As I said, just keep asking questions. There'll be like tiny little groups. Keep asking me questions, and Mark as well. So yeah, let's go. So the reason why I feel this is so important. So the likes of Tableau, Power BI, Microsoft, Amazon, they are investing so much money into making this work. So to make data analytics work at scale. And there's so much money going into it. For example, Tableau will allow you now to define a metric. And let's put that into our the way we work. So imagine you've got the metric brand awareness for a particular brand. You're in the kind of organization where you're actually tracking this daily, weekly, something like that, so really regularly. So you can define it, connect that to your data source, and then it will give you that top level figure whenever you want it. But what it will also do is the background AI about why that number is going up and why that number is going down, without you doing anything. But what you can do is say, determine that based on these metrics. So if you want to look at demographic filters and things like that, you can tell it to do that. And then you can get it to send alerts to your team if it drops or if it goes up. And it's like, for me, I'm going to lose my job as a dashboard person because they've actually just automated it. It's not that simple, but and it's not that good yet. But it's getting there. It's really getting there. If you then move away from the kind of the big behemoths of these corporate world, open source is still going and still going very strong. So you can download a machine learning algorithm that will translate any language into any language. And you can run it on your machine, it's all completely free. Mad. Other things that you can do key driver analysis. I mean, most people have done this already, but there's like random forest algorithms. You just run it on your machine, it's done. It's in there. Sentiment analysis, you can do it for free on your machine. It's mad. It's just moving so fast. And it might annoy if there are software companies in this room who are trying to go, well, you do sentiment analysis better than anyone else. It's that you do, but you kind of put yourself in this box quite maybe too soon because it's moving so fast. And you need to develop a way of actually going, well, this is my data. I'm going to apply this tool this week, but next week I'm going to apply this tool. And so you need to have your data in a structure where you can keep using these things. Now the challenge that I find is that survey data is a bit awkward. If you, just a quick show of hands, Who's used things like Tableau before? Who thinks they've had success with Tableau? Okay. Same with Power BI. Is that similar kind of feelings? It's kind of tricky. And it's tricky because survey data is clunky and horrible. Now, Tableau is very good at selling. So is Power BI. They're really good at selling what they do. And what they do, they give you these example workbooks, which are quite nice to work with. So I've put this on here. So they have these data models, which is a Tableau, they call one called Sales Superstore, I think. And they have these kind of quite simplistic, but very meaningful models for many people. So imagine you're a retail business and you want to do dashboards on your product. So what you do, you have your table, which has got all of your orders. So you have an order ID, you have a store ID for where that product was sold, you have the date ID, you have quantity, sales, profit. There's going to be a product ID in there as well, so I'm just going to steal that. Do that with PowerPoint. Right. So that's your big table of data. That's where all of your information is, and then you just link to it. So you link your store IDs here, you link your product IDs here, if you can think, your date IDs, your customer IDs, and then what's lovely about the way that Tableau works or Power BI works is that you go, okay, I want to do produce a chart that looks at location by sales. And so you grab your location, and then you put that there, and then you go, I want sales as my axis, and then if I had a pen, I think it's right down here. Thanks. It would then just draw it for you. And so these would be categorical things, and you then have your chart. And then you go, okay, I want to filter it, and I want to filter it by product types. And so you put your little filter in there, done. And then you filtered it, and people go, wow, isn't this amazing? I want to use it. And then they buy it, and then they try and use it with survey data, and then they fall over. So, first group activity. What I want you to do, you're kind of almost in pairs. If you're not, if you can just bundle up a little bit, that'd be grand. What makes survey data so hard? So I want you to chat to each other. You can chat to yourself or someone else. And come up with three things which make survey data hard. I'm just going to give you one more minute. Okay, if I could bring you back and all look at me. Okay. Quite a lot of discussion, quite a lot of volume, quite a lot of pain, I think. So who wants to start us off with some of the pain that you have?
Multi-choice data.
Multi-choice data. Yes, Pat.
Grids.
Grids. Okay, what do you mean by grids? Just
Grids. Well, lots of things that mash together.
okay.
Loops. You know,
Text
Okay.
question.
yeah.
A lot of text.
Text questions. Yeah, fine.
Loops.
Subpopulation.
Subpopulations. So explain that a little bit more.
Well, the base.
The base changing.
The base
between
keeps
the
changing. You know.
Yep.
Yeah.
Perfect.
Hierarchical data.
Yes. You're going to have to keep writing quite fast, I'm afraid. Communicating metadata. Oh, yes.
Waves.
Waves. Yeah, and they keep changing it.
Confusing labels, queue numbers that don't mean anything.
Yeah.
The order and answer was selected.
Ordering
first, second, third.
Yes.
Pipe loops.
Faster.
We've
We've got more pain. We've got
What was
more
this one
pain.
you said?
Bad labelling,
Bad.
or label difficult challenges.
Weighted data?
Weighted
Redundant
data.
variables.
Yeah.
Missing
What was that
data.
one? Sorry, up there?
Redundant variables.
Redundant variables. Yes. Yeah,
Missing
made my
data.
life. Sorry.
Missing data.
Missing data.
The
Yes,
definition of missing data.
Yes.
Not
has to be true of all data.
not field, refuse to answer.
What do you think? Sorry, I was chatting to Andy, sorry.
And then now you have duplicate.
Okay, there's a lot of pain, I think. There's a lot of pain on that board.
Came out quite quickly as well, didn't it?
Yeah, well done.
Changing metadata. The fact that it changes all the time.
Oh,
Yes.
yeah.
And it's so much of it.
Oh, we're going to repeat this wave, but we're going to change half of it.
Yeah.
Love it. Fact. So, as I mentioned before, I've been doing my job now for 3 years, running the company, and I've used the same model for every single project I've ever done. Same one, and it's worked for all of them. And it's varied from staff surveys for the NHS to fashion design concepts, all sorts. The weirdest, the wonderfulest, the SPSS file with 85,000 columns. It's like the same thing. So what we need to do, or what I'm going to show you, is how we can answer that pain with a model which looks something like this. If that's the plan. So if we can join those two things together, we're like, whoa, made it. So what I'm going to do first is just talk a little bit more about theory, about what data warehousing means. So if you could raise your hand if you know what a data warehouse is. Ish.
The next question is build one.
Yeah.
Then you get to it.
So for me, data warehousing was like a couple of years ago. I just thought it was one of these just faddy terms, which was just like big data, and she was like, "What does that mean?" But the more I looked into it, there's actually quite a lot of science and study that's gone into it. So that's what we're going to come into now. So I need 4 volunteers. Okay. Yes, Nikki. Richard, you look keen. What? Come on, Richard. You've told me what to do all my life. Yes, please. And then I'll bring that one back. Be very careful. Okay. So, come on. Right, I need 2 more. 2 more, please. Come on, Dex. JT, come on. Fab. So the challenge which businesses have is that they get a lot of data come through, and so they need to have like a nice process, a nice model for how they actually process that data. So typically it works like this: you have your data sources. JT, you're the data sources man. You then have your data sources, and they go into a staging process. And now, Bex, you're the most important one.
Obviously.
Data warehouse. That's you. And then that then goes to your analytics, which is more exciting. Logic. So this is your typical kind of process that things go through. Data for companies can come in a massive number of different ways. They could be live streams from social media, it could be their orders, it could be anything, all sorts. And so they then need this staging process to massage that data into the right process. Typically that's done in Python, SQL, all these other weird and wonderful things. Then we come to data warehousing. Stand over here. So then we have the data warehousing, which is actually how do you structure that in a nice way. So if you imagine the actual word warehouse, you want to go into a warehouse, you know where everything is. So that's almost the concept that we're trying to get with a data warehouse. So we're trying to know where all of our data is. We know where all the shelves are, and it's all kind of organised in a nice way. And then you have your analytics, which is the fun bit, which is the stuff that is easy to sell because it looks cool, but it's really hard to get to that point because you've got to do all those bits first. Cool. So, for the data warehouse part, sorry, still stand open to shut it. There are a few different models about how you can do data warehousing. So there's the kind of fairly old-fashioned one called Inman. You can hold that too. You're going to have lots of things to hold, I'm afraid. So Inman is quite you take your data and you really kind of make it a very relational database. You take it to several normal forms and you have lots of IDs and lots of joins, but it's really quite difficult to work with. And then what you then have is kind of what's called data marts, which prepares the data for different departments, and then that goes into the analytics. So that's quite an old-fashioned way of doing it because you have so many joins on the data and it can get quite confusing. Then there's another one, which is like super cutting edge, I suppose. And this came about from
OBT.
OBT, so one big table, where people just said, just put them on one big table, like just go nuts. And I think it came from Google and their BigQuery and all that kind of stuff. For me, that's a step too far right now. That's like a bit too hard to grasp, and I'm a bit too nervous to kind of go, let's do that.
Can I ask a question?
Yeah, of course.
These that you're talking about, do they or do they not work? When you said you ran every survey through this process,
Yeah.
is that including those? Or
No,
not?
I didn't use that.
Right.
These are just the other examples of data warehousing. The one I use is this one. So this is the one. So you can hide the other ones now if you want to. It's good. So there's one called. Perfect, thank you. So the one called Kimball, which was developed by a guy called Ralph Kimball. It's also known as dimensional modelling or star schema, if you've heard of that term being thrown around. So Kimball is the one that I use, the one that's kind of fairly easy to understand, and I'll go into the reasons why. Cool. Thank you very much, everyone. Well done, you. Well done. So, if we have a look at this kind of need for data strategy, and just re-emphasising that these companies, all of us, we get so much data coming in, and we need a strategy for actually how we work with it. Can you be my righty scribe? Yeah. So the first point is that there's many data sources. Even just with our surveys, you could almost consider every single survey as a separate data source because it's so bonkers and different. And so all of a sudden, if you do 200 surveys a year, you've got 200 data sources. The next one is that we now also have many consumers of that data. So more people are asking to get access to it. It could be the project manager, product manager, the brand manager, or external third parties. You may want to sell that data to someone else. There's many more consumers that we need to think about. Then the other part is that data needs to be optimized, both for speed, but also cost. Because when we're talking about this kind of data, we're looking at, you're starting to push into the cloud, putting things in AWS, and soon the money starts coming up. And then the final part, which I think is the most important, is just like the mental clarity of having your data in a way that is easy to understand. I think something that's quite common within our industry is that projects are run by individuals. And so if that individual goes on holiday, it's a bit of a nightmare because it's only Dave who knows how to manage that project. And there's some syntax that he's got on his machine. And it's just like, how are we still working like this? And that may feel like, you may go, oh, that's us a little bit. It's everyone. Everyone's doing the same thing. And so that's why it's so important. Like we need something that captures all these things. So coming back to Kimball. Oh, sorry. You have to make sure you can read Mark's writing, I'm afraid. Oh, good. Right. So coming back to Kimball, if we look at the kind of more formal definition of what Kimball's all about, and this is like super high level. like, if you want to get a book on it, it's like that thick, and it goes through the ins and outs of how to do everything about Kimball. And people spend their lives kind of making it super good. I'm not going to do that right now. So, first thing is that it's easy to understand, maintain, robust, flexible, and it fits to a lot of analytical requirements. So that's the first thing it needs to be. Then there is typically a fact table. Here is our fact table, which is the orders in that case. And then they're supported by these dimension tables. These are a dimension table, and they all fit together to look like a star. Dimensions. And then the attributes in our dimension tables are very descriptive, so they can tell you all there is to know about it. What I found quite weird coming into using dimensional modelling is that it's very denormalised. So the view is that these dimension models, you may sometimes have repeated data in some of those columns because you're not normalising it. And as a data person, you're going, this doesn't quite make sense. But the idea is so that when it comes to your analytics, you can just drag these things in and not have to do all these joins yourself and make sure you're not doing them in the right way. That being said, sometimes it makes sense to have little tables come off these things. So you may have another table that comes off like that, and you may have another one that comes off there. And that is where the term snowflake comes from. If you've heard of snowflake schema, it's like the extension of a star schema because it's now starting to look like a snowflake. The challenge is that if you do that too much, you're then in this kind of crazy problem again that you've got too many things going on. So it's all about that mental clarity and making sure you've got things in an easy to understand way. Okay, that's theory of Kimball data warehousing. Any questions? Well done.
So if you go with a Kimball star schema, you then have a choice of how to implement that.
Yeah.
So which is an actual database of some kind.
Yes.
Okay.
Yeah, and that database can be anything you like. It's more of a kind of a framework or something. You could have it as just each one of these could be a CSV file. Doesn't really matter. Or it could be in a database.
Okay.
Do what you like. It's the framework, it's the concept, it's the theory that goes into it. And part of the benefit as well is that if you then hire someone and say, our data's in a Kimball methodology, they go, gotcha. And you've just taken away days of training for that person because you're not trying to explain what different weirdness is in each individual project that you have. So you have this consistency.
And you have an ETL process to load the data into your, or convert the data from raw into your schema, right?
Yeah. So the ETL is the loading process from your sources, your JTs, through the staging. So that's the ETL process, yeah. And then there's kind of notation that you typically use. So your fact tables have you typically denote them like that. So you call that one fact, sometimes you just put FCT. That one's dim dates, that one's dim products. And these are your dim customers, which always makes me laugh. And then you've got dim stores. But the idea is that when you look at your database schema, you go, they're my dimension tables, all my data's in the fact table, I'm away. And then you go. Okay. Any other questions so far?
You have an example, right?
Oh, yeah. One of the most important things about Kimball is this thing called define the grain. And that's like the granularity of the data that you're storing. So you could, in market research, store all of the percentages that have come out for all your different aggregates and all your different cross breaks. But one of the most important things about Kimball is that your measures are additive. You can add them up. You can't add percentages. And then you also want the flexibility to go, the client's changed their mind. They want to put an extra different break in it and they want to filter it by this thing. If you then have to go throw away all of your percentage data and then redo your data, that's rubbish process. What we can do now, because data storage is cheap really, is just store everything respondent response level. So that's what our grain is. So coming into the actual model for us. And it's not that revolutionary, really. You'll go, oh, makes sense. We do that already. So this is our fact table. So for every survey ID, there's a response, there's a variable, there's a value, and then you have this value text. And I've also created one called value float. So if you need to, I don't know, they enter some sort of number, their age as a number, you then want to be able to average those. And so they're stored a little bit different than a lookup. So we have our responses. Then the other thing that we have, bring this over. Is our code book. I mean, this doesn't seem that kind of revolutionary. I think many people go, yeah, this makes sense. So here you have your variable. You have your variable label, which kind of explains what that is. And if you've used SPSS, which hopefully most of you have, sadly, and cry a little bit, you have your value labels, you have your value IDs, and then you have your value labels. And I kind of move a little bit away from the official, traditional Kimball method in this, in that all of these items here, they're joined on a single key. So store ID links to store ID, date ID links to date ID, kind of thing. But what I'm doing here is joining both on variable and value ID, which is kind of like, you shouldn't really do that. But for mental clarity, it just makes sense. So just go with it if you're a big kind of like Kimball fan. So then the other things that we have, we've got a few more IDs on there. We have our surveys. Take time. Good. We have a little survey table. Now you'll see that these are quite brief because that's what your job's going to be, just to fill it out a little bit more. So you have your survey ID, so what was the actual survey name? You may have a code, you may have a description. That's for you to discuss in a minute. And then the other part, which is quite useful, is having one called respondents. And you have a respondent ID. So I found this quite useful when I'm doing my visualizations because, for example, I want to filter by region. So if I bring the region variable into here, I can then filter it just by drag and drop. And so it just makes my life easier. So these should be your kind of your common things that you want to filter your respondents by. But I don't want to go into too much detail because that's going to be your job. So what we're going to do is ideally be on big tables and you can share stuff, but we're not, so we can't. So what I'd like this kind of section of the room to do is to think about the dim surveys table. And what additional attributes would you want to put in there just to make your life easier? And you can be as verbose as you like, you can put as many in there as you like. So what would make your life easier to help you identify a survey or type of survey? So this group here, you're quite a biggish group, so it's not too distinctive. So then I'd like you to do codebook. This is kind of the bigger one, I suppose, and there's lots of you. So what additional things would you want to put with your codebook to help you do your analysis better? And again, you can put as many descriptive things in there as you like. And then this final group over here, you can choose which group you want to be in, otherwise it's just you two. You're looking at respondents. So what additional respondents would you like to do? Now to give this a kind of bit more real edge, I picked a survey. So have many of you heard of Pew Research in the US? Mm-hmm. They do lots of really kind of good national level understanding what's going on in politics and things like that. So there's one called the National Public Opinion Reference Survey, 2023. New update is coming in 2024, very soon. So I've got an example of the questionnaire, which might be useful for your codebook people and responsive people, maybe a little bit for you guys as well, just to kind of help trigger some ideas of what additional attributes you would think about putting into the codebook. So I've got some little bits of card, of course.
You
So,
don't want to refine the responses.
sorry,
The responses table.
what about it?
I think it needs refining.
How would you refine it?
Add some paradata in there, like the time you spent on the response.
Yep.
You could also have the number of clicks, the number of keyboards typed, the keystrokes.
Do you want to move?
You could have.
If you want to move, move.
Oh, is that?
Yeah, that's what they're doing.
Oh, that's what they're doing.
Yeah,
Oh, sorry,
they're doing
sorry.
a survey.
I thought you.
That's
yeah.
your own. It's a team on his own, you know.
Sorry. I'm sorry.
Running out of Okay, so just to bring us all back into the focus. Woo! Look at me! Stop looking! Me? Right, okay, good. So this team over here, they were looking at surveys. So something that they thought would be quite useful to have as a client name in there as well. So who ran it? Kind of quota information. I'm just going to stop these in any weird way. Job numbers, yeah. Fieldwork start and finish date, yeah. Template ID, yes. I suppose if it comes from a particular type of thing, that would be a good one. Good. Respondents, because code looks hard.
We had more, by the way.
Sorry?
We had a few more. We didn't have enough stickers.
I know, but you get the idea. Okay, so for respondents, we've got language, we've got community area. Was that question in the survey?
Yeah.
Cool. Race.
Political party.
Political party, nice.
Marital status.
So this is all getting quite specific for the project, yeah?
Age.
Fab. And then for code book, what have we got? I think we can So we have whether it's a hidden or system variable. I'm just going to put them down here. Filtered. What do you mean by filtered?
If it is, if the question is asked of everyone.
Seen on path.
Yeah. So yeah, information almost sometimes like the programmer notes of where some people sit down this way than the other. So the idea is then, again, if you're in your super Tableau dashboard, you can just hover over and you can find out who this question was asked to and all the information about it, rather than having to refer back to a weird document somewhere else. Hyped text, that's an awkward one sometimes. Size in Charles. What's a size?
Characters.
Okay.
Limit.
Character. Yeah. Okay, cool. Very nice. Variable type. Yeah. So sometimes it's quite useful to say whether it's a single select, multi-select, that kind of stuff. Yeah, you all got it. Selection order. What does that mean?
So,
Otherwise, choice, you sometimes collect that this one is picked first.
Nice. Randomization. Sometimes that's stored in a separate variable, which is also done. But
whether there was a rotation or a randomization.
yeah, randomization got in there as well. Scale labeling. Derived. Yes. So sometimes what you could do, and again with a model like this, is that you may want to supplement your data with other things. So that could be like sending it to do a algorithm or something that adds up your segmentations in a particular way, brings it back, and then you just add it to the bottom of your fact table for each respondent, and then you add a new variable in here, which is the derived variable. Super cool. Very good. So, that's a shame I ran.
What would you have added? Anything there?
Well, I will show you a real example of what I've done. Okay, so we now need to move these out of the way. It's not all completely analog, I'm afraid. Okay. So the annoying thing, which is what most of my presentation was last time at the ASC, how do we do this? Okay, there's my slides. So we typically get our survey information, a lot of the survey information that was in our codebook, the additional things, is actually all written in a PDF file, which is the most frustrating thing in the world. If it's not a PDF file, sometimes you can't even export it from the survey platform.
Yeah.
I mean, it just drives me bonkers, and that's the way it is. So I'm not going to update it now because I've done one already. The other thing is your data also, sadly, sometimes looks like this, but in an SPSS file. So my data source for this particular project is SPSS because that's what Pew Research put on their website, so that's what I've got. So your typical thing, you've got each variable going along the top. I can't remember how many variables we have in here. Doop-a-doom, anyone have a guess?
260.
80, not too many. So it's quite a simple survey. A lot of the questions are single select ones. There's 2 multiple choice. Fab. So that's that bit. So what I then do, and is
Where did those files actually come from? They're exported from SPSS or something? Or
I got them off their website,
okay.
and so they've massaged them a bit as well. So they've put some recoded variables in there and
Okay.
stuff like that. So if I then close this down, I'll just find it. And so because I'm lazy, I developed a little bit of software which does this kind of ETL process for me. So what I did, I put the data in, put the survey data in there, and it ripped apart the SPSS file and then booted the SPSS file as far away as possible. So it's just taken everything it can from the SPSS file and then puts it into the normalized framework that we want. So we have things. We have a fact responses table stored in Postgres. We have a DIM codebook table stored in Postgres. We have a DIM surveys table stored in Postgres. And so what I'm then able to do is say, right, I want to download my metadata. I want to download my codebook. And so when you do that, let me just do this in case I show anything I shouldn't. You never know. It looks hideous. That one? No. Okay.
It's coming. It's coming. You can hear it. There it is.
It might take a while. I didn't realise I actually turned the whole thing off. But with SPSS files, you typically get just those 4 columns. Ooh, it was almost there. Okay. So what we have here, I call it survey load ID, but it's semantics we're talking here. We then got our variable ID, we've got our value ID, we've got a variable label, option label, and question ID actually isn't actually coming out in our data, so I'm just going to delete that. So that's typically what comes out in our survey data. And it's not that useful, so we have to supplement it so much. So this is why TS API is so important, because if we could actually pull all that information straight from the survey platform in one go, I wouldn't have to employ someone to manually copy and paste all of this data from a questionnaire into the codebook. So, as I mentioned before, here's what I prepared earlier. Okay. So what I've done here is I've enhanced that data. So I've added what I call a variable option. So this is how I'm doing multi-selects. So for those variables, I'll start again. So there's a question here about what social media platform do you use. It's all kind of buried in the variable label text of which one it is they actually use. So I've extracted that into its own variable. Then going across, I've put in a usage column, which I think is something, it's similar kind of coding to what you mentioned. So some of these are questions, some of these are meta. So it could be, when did they open the survey? So it's not physical things that they put into the survey, but it's stored within the survey itself. Then I've added a question ID, because as you can see, these social media usage questions, they all have different variable IDs, but they're all actually the same question. So then if you add a column that says these are all the same question, that makes your life easier, because then you can just filter by question. Then if you go across a little bit, I've added a question order column, because if I sort by my question ID column, it'll come out in a random order, which won't make any sense to anyone. And then I put in the full question text. I put in the variable base description that was in the questionnaire. So I've just kind of just downloaded as much as I could into the Excel. Again, because I'm lazy, what I've then done is then I push that back into the tool which we've developed, and then it stores that data back in the Postgres again. Now, what I've talked about is survey, dim codebook, fact responses, but not our dim respondents. So dim respondents can change and it's variable. So again, me being lazy, I'm having to write the syntax to bring it around and put it into a separate table depending on how I'm feeling. What I did is added another column in here which says, what do I want to be in my dim respondent table? So what it does here is, for these variables, it will create, this is quite a weird concept, a bit abstract. So it will create a variable in our dim respondent table called C region, and it will take the values from option label for every single respondent. So then when I join it all together with the rest of my data, I've then got that filter that's easy to drag and drop. Make sense?
No. Because all of a sudden you cannot superpose your surveys. If all of a sudden your respondent table is different from survey to survey, then what's the point of having a survey ID in there? You know, like, I understand the need because it's nice to drag and drop in Tableau, that you can filter by something.
Yeah, I get you. Yeah. It depends. And there are different things you can do depending on the different surveying things. So at the moment, I'm storing these as tables. You could, for each project, define it as a view rather than an actual table. So then that view is a lot more dynamic and dependent on what you're trying to achieve with that particular survey data.
Because I thought you were going to say having age in there is anathema. You know, like it shouldn't be in the respondent; it should be in the responses, and then you can find it another way.
So yeah, it is in the responses. Everything is in that responses table. You're just using the respondents table just to make your life a little bit easier.
Yeah. But
you don't always have to, as I'm going to show you in a moment. So this is kind of what it looks like in Tableau. I've joined those tables together, and then what we can do is down the side, just like the Tableau demos that they like you to do, you can bring in your, let's have some question IDs, let's have the question text. Then for each question text, I want to have the, what are they called? Option labels. Then for each one of those, I want to have the weighted counts. I don't just want counts. So that's the weighted counts. And then I want to change that into percentage of total. I've now got every single question with their weighted counts going down. If I then go, actually I want to do this by region, you drop that in, and then you've got all of your crosstabs.
When you're saying question, does that mean a format response? Let's say, what conference do you know? You have then 50 questions or one question?
Say that again, sorry?
Well, a question, what conference do you know?
Yeah.
Be one question in the survey, but 50 variables in SPSS.
Yes. Which is why I added that extra column. If we go to the one which has got multiple responses in it, I think it was snooze. Snooze. So here it's actually just bundled everything together and not separated it out by those separate things. But I added something in my codebook called variable option. So if I drag that in and then go back to my smooths, you can see it for each answer option. You've got the counts for each one. So you have to kind of screw your head up in this like weird knot to try and make it work. But once you're there, this is actually a really repeatable solution. And then I started getting a bit crazy about it and going, well, could I actually just put this into a more interactive dashboard? So what I've got on the side there is all of the questions, and then you can click on a question and see what the answers are. And the colours are hideous, I'm sorry. But that top one at the top is, I've also split it by one of the other questions, which wasn't actually in my respondents table. And it's doing significant testing at 95% confidence level in real time. The little line is the average, is the national picture.
So if you hadn't done all this work preparing the data, put it in your model, it would have been very difficult to do this in Tableau, or you wouldn't have been able to do it.
Yeah, because I mean, you can load SPSS files into Tableau, but you'll get a column. You'll get one of these. Where is it? You'll get one column. You'll get one of these for every single item in your SPSS file, and you won't get that additional code metadata information. They only bring through the numbers, which is annoying. And then if you, this project's very small, there's 80 variables. When you've got 85,000 variables, you cannot do it. We just go, nope, not doing it. So that's why.
Are you proposing this as an industry standard?
Pretty much.
Yeah.
I think it needs
Can
to
I say yes? I think that's
so I don't have all the answers,
no.
but this works. And I've used it for the last 3 years, and it works.
Yeah.
And there isn't a project I've found where it doesn't work.
So barring a few queries from Jerome.
Oh, there'll always be some. Yeah.
You know, there are hundreds. You know? So,
And a lot of
we agree that the AV is you know, like the anti-theatric value is perfect. It's like you know, like we can argue about which variable is in which, etc. But of course, in principle, it's exactly how any survey database should be. So I'm not going to argue about yes, but you know, like depending on the base of the question, how do you get, you know, there are complicated things. We've not solved everything. We've not solved the hierarchy, you know, like in your example, which is very complex. But
I've got solution.
Survey database should be exactly like that.
And I think most survey platforms actually store internally in that schema.
Yeah,
Because they need to have the flexibility, and they cannot have different database structures for every project.
Mm-hmm. Yeah.
But if we're
So-
looking to get, sorry,
Yeah.
if we're looking to get survey data into the hands of more people, and we look through the eyes of a Tableau user, one of the many hundreds of thousands of Tableau users that just can't get survey data into their platform, what you've just done there, I mean, it really deserves significant appreciation, doesn't it? Like, you just sort of, well, I just did that.
Yeah.
Like,
And
most business intelligence tools.
again, because I'm lazy, I don't want to keep doing the same thing. So it's pretty much all automated.
Yeah.
So whilst I did that with pre-prepared things, it was almost real time, but I just didn't want to do a live demo. Because you never know.
So you also said there's quite a lot of manual.
The manual part is filling in that code book.
So who can do that? What sort of a person can do that? And how long does it take?
I've had Alex, who's co-presenting, co-chair. His son did it for me. He's 16. So can you put this in there? And it was a great work experience project for him, and he understood how relational databases work. Boring for him, but I paid him much more than minimum wage, and he was happy about it.
Andrew, so I've got a question, which might be a stupid question, but let's say we say, okay, this is the standard and this is what we do. Whose job is it to do this? Do you see what I mean? Like,
Yeah.
So I collect data in a survey software. Is it my job to do that? Is it my data processing team's job to do that? Is it the analysts who's changing the world so we're doing it like that?
Yeah, really good question. So it's weird for me because I do everything, and I wouldn't have been able to do this without knowing how each bit works.
Yeah.
So we may need to start changing the way that we structure our market research departments by having DP and all this kind of stuff. Because what you could do, that survey dashboard that I showed you there, that doesn't actually have anything which is unique to this project in it. Nothing. Because I'm not using the dim respondent filters, apart from at the very top where I've just put it in for giggles. This bit at the top here is actually completely dynamic. Any question you like. So if you want that to be the break, for example, come on, it will do that, and then it will do the break for that one. So there's a step here to get your data in the right structure. Once it's in the right structure, we can keep just adding to the bottom of it, assuming nothing's changing. If it is changing, we need to add a new column in our codebook that says, how do we align these surveys between waves or things, which aligns them.
I guess my question is, if I'm just doing the data collection on a project and the client wants just data, and they want to use it in Tableau or whatever, is it my responsibility therefore to deliver a database like this, or which obviously the software I'm using, it doesn't come out.
Yeah, I don't know. I mean, I don't know anyone that's doing it quite like this, to be honest.
I think it depends on the size of the organisation as well.
Yeah.
If you've got a team of data analysts with you, then chances are they'll already have a data warehouse if they're in a larger organisation. Because a lot of the finance and project data is stored in a similar way.
Because I think the issue is, quite often we're very small, we don't have in-house analysts. Sometimes our clients are very small and they're trying, because as you said, Tableau and Power BI are very good at selling themselves. And, we're going, well, you're not paying us to in fact, you just want raw data, so we're not charging for it at all. But they are very small and they don't have anyone that could. They're just using, Tableau or whatever themselves, and it doesn't work. So, maybe everyone needs that additional function somewhere.
The internal engine of dimensions is like this, is EAV. So when you've got like the MDD, the DDF, that's different. But when you do it, when you run it in SQL Server, when you collect your data in SQL Server, you probably do, then inside the model is EAV. So it's easy to do like an ETL that will pick the data from there and make it pretty.
So again, it comes down to the clients need to stop asking me to give them an SPSS.
Yes.
Right.
Give them a database export.
Yeah. But again, whether my clients would know what to do with the database export is.
We do have a solution for that though. We can have a separate conversation.
Can't ask everything.
A couple of points. We've been working in this way for 3 or 4 years as well. In a very similar way, Andrew knows how we do things. So I can vouch for this working in reality. A couple of things to note. I think as an industry, we've maybe a bit controversial here. The world outside of market research has an enormous amount of sophistication, money, and technical people getting on with this stuff. And the reason I'm part of the ASC is because I believe we can learn lots of things from the outside world and move our industry forward. So data engineers, data architects, the kind of people that ICT out there is hiring in droves for us, are handling far more complicated data sets outside of market research. So I think we've really got to take advantage of this kind of potential standard and this way of working, so we're really left behind. And as many people in the room who've worked in this industry for a long time, but we're working in small data. As you mentioned earlier, we know the project, we understand the structure, a single person can manage it, or a team from scripting to collection to a file format. Some of those are great standards, we're celebrating those, but it's small data. The world outside is doing this in every other type of data. And if our clients are marketers, they're getting their data in this format elsewhere. We're working with clients to configure their Power BI and their ETL processes to pull survey data in. If we don't keep up, they're going to circumvent smaller agencies, frankly. So I think it's our responsibility to take this forward. Lots of points there, sorry.
Thank you. And just example, you can just throw the same thing into Power BI as you can. If you want to use data query in Excel, you could do that. Put it anywhere you like. It does feel like the kind of the way to go, to be honest. Emily yesterday, she talked about kind of our moonshot. So for me, I compare building a dashboard to building a house. You start with the right foundations, which is your data, and then you build the structure, which are kind of typically your charts. Then you kind of do the wiring so that it's all kind of connected. So you flip one switch and the lights over there go on, the lights go over there go on. And then the final thing you do is you paint it. You apply your formatting, your fonts to make it look just right. That house analogy, where personally I want to get to, I want to build towns. I want to build cities where they all have this foundation. So almost the definition of what we're doing here, they're your building regulations. This is how you build these things. Now let's build. And so that's my vision.
Can I ask you a question? You may not be able to answer, but who do you need to be in a room to make this happen? If you're in control of making this happen, who would you invite to that room?
That person at the back, the CTO.
That's very expensive, by the way.
The survey platforms were brought on board. They would introduce SAPI, and we have a similar system. We don't do a lot of Tableau, but we do manage our metadata in a very, very similar way. And so anyone can take over a project and know exactly what's filtered, what's what. A lot of our grid, the codebook population can be deduced from the data itself, depending on the structure of the data. If we had more standardisation in the way that data was parsed, we'd be able to automatically populate most of those things.
There's so much variance, and I think maybe I'll get shot down for this, but a lot of survey platforms aren't developing anymore. And so to implement better ways of working, I struggle to see if it's going to happen. And so we just need to go with what we've got. And sadly, that's typically these old-fashioned file formats. Some of them are using APIs. Within the tool that we've got, I've hooked into Decipher because I used to work there and I know how it works. And so I can then connect to the API. It pulls all the data, and it pulls the translations, it pulls the question text, it pulls everything. So then the codebook exercise is really quick because it's just automatic. But then, I mean, it's the whole reason for SAPI. I've now got to write one for dimensions. I've got to write one for SurveyMonkey. I've got to write one for ASCII when that comes out. I've got to write. I mean, it's just a pain, to be honest. Whilst on the other end, if you have your data stored in this Postgres database format, it doesn't have to be Postgres. There are then tools which can then put it into Snowflake, into Databricks, into AWS, wherever you like. That bit's done already. What we need to do as an industry is do the other bit. We get data into the same structured, same format, which is expandable. You can do what you like with it. Right, I'm running out of time. I've run out of time.
Is it the data collection agencies though? The data collection platforms you want in the room? Like, is it them that need to honour a certain?
I just don't think they're going to do it. I just don't think they're going to change.
What you need to do is disassociate yourself from any of these kind of proprietary formats anyway. So you really got to it's your initial ETL. So you're going to deconstruct this proprietary data format into just raw data that you're going to put into your data lake or anything like that. And then the world's your oyster. You can create this task schema. It's really quite straightforward. It's not as complicated as it's hooking yourself into these proprietary formats in the very first place and trying to adhere to what they're trying to impose on you that's causing the problems.
How do we get it to change?
You don't, just deconstruct it. As Andrew's saying, they're not being developed anymore, and if they are, then great, go with that. But if they're not, literally reverse engineer it into just raw data.
I think a lunchtime conversation.
Thank you very much.